Good morning. Hello, everyone, and welcome to our webinar. GNSS RF interference is what we will be looking at today. Excited to have all of you here today. As we have quite a lot of information to go through, I'll just jump straight to this slide. So who from the team is here today? My name is Melina. I will be your moderator today. We also have Milena, who will moderate the Q&A session. And then the most important person, except from you guys, is Bernd Heidmann, who I will present closer on the next slide. He is our key speaker today. Just first, some housekeeping stuff. The webinar, as always, will be recorded and sent to you automatically, so you don't need to do anything. We really encourage and invite you to ask questions throughout the webinar. You can post them at any time, and there will be a Q&A session at the very end. And how to place a question, you see on this slide, so it's shown on the right. And if we, for some reason, didn't have time maybe to cover your question, we will get back to you in written form, but you can also use the contact options presented at the very end. So Bernd is with us today. We're very excited to have him present this webinar. He is our product manager for the M9 technology platform, and he is a member of the product strategy team of positioning at U-blox. Prior to joining U-blox, he was the product manager for RF products at Huber and Sooner. And before that, he was in the mobile radio base stations business at Siemens and Nokia in different functions. So quite an impressive background. We're very excited to have him here today. And with this, I will hand the word over to Bernd, who will dig into the agenda.
Okay, thanks, Melina, and welcome everyone to this session about RF interference. I'm glad to talk to you today, and just quickly want to introduce you to the agenda. So this session here, it's basically an introduction into the topic of RF interference, because what we got feedback from customers is that there's some uncertainty about. So basically, this session gives an overview. So in the first point of the agenda, we will talk a little bit about what is RF interference, and then there will be a second point, how to mitigate RF interference, and this is a more general introduction into the topic. We might offer even another webinar to go more in detail, but one thing we go into detail, and this is the third point of the agenda, which will show how we can use the U-blox M9 products to find out about RF interference, and this will help you to then also mitigate RF interference. Okay, so let's get started with the next slide then. So looking at a very simple picture on the right-hand side. So what is the GNSS receiver doing here? Basically, the aim of the receiver is to catch the satellite signal, what I highlighted here, the desired satellite signal, to basically provide position, velocity, or time information to the application or to the host system. And of course, it's not only the case that the receiver will receive the desired signal, but it will also receive some other RF signals, and this we call RF interference. And the important point why we talk about this topic is really that RF interference has an impact then on the GNSS receiver and can basically lead to a change in the reported information from the receiver. So later in the presentation, we will also see what are the impact factors and how serious they are from the certain sources of RF interference. So on the next slide, we still ask the question, what is RF interference? And RF interference is really the unwanted impact RF transmitted from some electronics or some devices to the GNSS receiver. So on the picture here on the right hand side, again, we see the desired satellite signal, which we want to catch with our receiver. And there, for example, there's a cellular transmitter nearby and sends some frequency, RF frequency signal, which will be catched by the GNSS receiver. And as we all know, there are more and more wireless devices in the field, and not only in private life, but also in the industry. And if we talk about 5G, there's even the plan to have more devices there. And this results basically in an increase of this topic of RF interference. And mentioned already on the last slide, this can have a bad impact on the GNSS receiver. It could mean degraded performance, or it could also mean that it will completely disable its function. So it's quite important to understand RF interference impact on the GNSS receiver and also try to mitigate it. So on the next slide, we see just examples. What could RF interference be? On the left-hand side, you see the very big chart there about the United States frequency plan. So there are lots of frequencies for a lot of applications. So for example, an RF interference for the GNSS could be nearby Wi-Fi or cellular modem. And then on the right-hand side, this is something else, and this is what I wanted to discuss then more in detail with U-blox M9. This is a second case. There could also be RF interference by the application board itself. So for example, some clock generator or DC-DC converter circuit on the board, which creates some RF interference for the GNSS. And this is quite close by to the GNSS receiver, so it's also very critical. So how can we then distinguish this? We see on the next slide between different type of RF interference. And there's on the right hand side again a small picture there, different type of RF interference. So if I start on the top right, there is a multipath GNSS signals, which means the reflected GNSS signals by some houses, for example. This the receiver has to handle. Then we discussed already all kinds of wireless transmitters. Also, we mentioned the board design issue you might have on your application board. And then there's a particular kind of RF interference, which is jamming. So this means that someone tries to disable the GNSS by sending a particular RF signal towards your device and with the intention to disable your function. There's also spoofing. Spoofing means that someone tries to fake the position. So the receiver shall report not the real position of it, but a fake position. And you might know some videos from YouTube where people show how to bring some autonomous cars from their right way. So that's quite dangerous. And so if we look at these different types of RF interference, it's important to distinguish unintentional RF interference and intentional RF interference. So the last one I mentioned, jamming and spoofing, this is intentional RF interference. Someone wants to basically influence the receiver, the GNSS receiver, in a bad way. And the unintentional RF interference by other devices, this is basically something you cannot avoid. And then it's quite important to detect it, and especially jamming and spoofing, as it is a security risk we just discussed. It's important to detect this one, and the U-blox receivers, they detect a spoofing and a jamming attack and report them to the host or to the application board. Okay, that's it for the quick introduction here.
Thank you, Bernd. Very interesting to get that first overview of what RF interference is all about. And we actually would like to turn to you now, audience, and we would like to ask you a question here on RF interference. And I'm gonna pull that up for you. And you see that here. So what kind of RF interference is the most challenging for your application? Please select one of the following. So spoofing, jamming that Bernd just talked about, multipath signals, board design issue, or wireless transmitters. So I am giving you some time. I see the results are coming in. Very interesting. I will launch them in just a minute. So before closing the poll, I'd just like to remind you about the Q&A section at the end. Please get your questions going. And we really look forward to receive those. So I'm going to stop talking and I'm going to show you. Let's look at the results. Yeah, it's a bit spread out. Board design issues, wireless transmitters seem to be the top ones. Thanks a lot for participating. I'm closing this one and I will hand the word back over to Bernd.
Okay, thanks, Marlena. Hey, that's quite matching with what we want to present here, so pretty interesting. And yeah, let's see what we can do here, how we can help. And yeah, I go further. We discussed several types of RF interference just before. And now also it's important to understand, okay, what are the impact factors to rate you know, the strength of RF interference, what it could mean for the GNSS receivers. So basically, there are three factors. There's the frequency band, so it very much depends if this RF interference is in the same frequency band or a similar one. We will go into detail then later on. There's also the received power level. Is it high? Is it very low? Is it, for example, higher than allowed by the specification of the GNSS module? We will also later on see a detailed slide about that. And what about the signal coding? So will the receiver understand the signal coming from this RF interference source? So, for example, we discussed about spoofing. So people try to provide a separate readable or yeah, understandable format, and then the signal coding is the same, which is more of a challenge for the receiver than if there is no coding or different one the receiver will not understand. Also be aware if we talk about the frequency band, for example, this is an impact, of course, for the receiver, and it very much depends now what type of frequency it is. And this we see on the next slide, a little bit of a detail. There is basically the so-called in-band and out-band signal. So basically the radio frequency band on which the GNSS device receives the desired satellite signal is called the in-band. And the rest of the frequency band is then called out-band. And basically the out-band is not of interest for the GNSS receiver. And the in-band, of course, there is a conflict. If we want to receive the satellite signal there and there is another signal in the same band, that's really a challenge for the receiver. And of course, there are different measures how to mitigate in-band and out-band. We will see later. We have a look what we offer there. But on the next page, I want to highlight the second important impact factor, which is the power level of the signal. And there it's important to say that the GNSS receiver can operate under certain power level of RF interference. But if the power level gets too high, it could mean that it disables the function of the GNSS. And there I mentioned also, please have a look in the data sheet of the product. You can see what the maximum allowed power level is. And if this is too high, basically you overdrive the RF path of the GNSS receiver. And later on we see a detail there. For example, if the low noise amplifier, which is one part in the RF path of your circuit, it could maybe get overdriven. Okay, then in the next slide, I summarized a little bit what is about these impact factors. So you see a table on the right, and I listed all the different sources, and I put information there, what is about the frequency band, the power level, and the signal coding, and what you can expect for different cases. So I think quite a lot of people they face trouble with wireless transmitters and maybe board design issues. So we can have a look there at what is written there. So wireless transmitters, they can of course have in-band or out-band frequency there. Relevant, and as I mentioned in the previous slide, for example, if you have a LTE 800 megahertz band cellular receiver, the first harmonics will fall into the band of the GNSS. So this could be, for example, quite critical for the GNSS. And then the power level, if we talk about wireless transmitters, is reasonably high. So the signal coding, it's different, so that's not a problem, but we see that already 2 of the 3 impact factors, they are given. And the board design issue, there it's could be a similar setup. There usually the power level is lower. So also for the board design issue, we will show later on a video where you see how to detect this kind of stuff. Then I put in red, I put spoofing and jamming. Maybe start with the jamming. There, usually if someone will spam you, it's a very high power level. And this will probably disable the GNSS reception at all. So independently if you are in the in-band or in the out-band, because the power level is just too much. For spoofing, it's basically the same signal we can expect as for GNSS, desired signal from the satellites, and of course it's in-band and the power level is reasonable. There we need to find another solution, but why I put this in red is the reason it's a security attack. Someone wants to change the reported position or maybe disable your application at all. So there we need to take care about. And on the next slide, I quickly summarize what could be the impact there. I briefly discussed already on the previous slide, and this is, of course, it's just a general advice here. So if we talk about multipath signal, wireless transmitters with reasonable power and board design issue with reasonable power, the impact usually is lower accuracy of the GNSS receiver. But you will not face the situation that it disables completely the function. It could also be if the receiver starts up, it takes a little bit longer to report the first valid position. The topic for spoofing and jamming there is that if they are successful, then for spoofing you will see a wrong position and the receiver will report your time and velocity and position, but it's a fake position. For jamming, if this is successful, there will be no PVT information anymore. So this could be, as mentioned on the right-hand side, it could be a heavy impact for your application. Okay, that's it for now. In the next section, then we talk about mitigation.
Thank you, Bernd. So let's just let's get the second poll up. It's time for you guys again to be active. We would like to know, does your device or application suffer from RF interference? And please select one of the following: no, not now, maybe in the future design step, or yes. And get your questions going. We are ready for answering them in the end of this presentation. Just as shown in the beginning, you place them on that little question mark, and we will read them out loud and make sure you get an answer. All right, so I'm closing down the poll, and let's look at what you have answered. Okay, this is interesting. 53% said yes, 31% maybe in the future design step, and 16% actually are not experiencing this at all. Thanks a lot for participating. I'm gonna hand the word back to Bernd.
Okay, thanks. Yeah, quite interesting. So the topic is an interesting topic for you. This is good. So we are not talking about something which is not of any interest. Okay, so let's get into the topic of mitigation. What can you do? So here again, I mean, we narrow this down maybe in a further seminar. Here it just gives an overview, and you know, the intention is that you get an understanding what the GNSS receiver can do and where you can also do something. So if we go through the different sources of RF interference, there are certain types of mitigation. So for example, for the multipath signals, the mitigation is used is software, and the GNSS receiver takes care about it. If we look at the wireless transmitters, usually we have hardware filtering for this. We look into detail in later slides. And also this is part, let's say, of the GNSS RF path. Then there is this board design issue. There it's also a matter of the hardware design we discussed already. And this is something you could do something, because it's influenced by your design if you design the application board. And then there is a spoofing. Spoofing attack is usually mitigated by software. And for jamming, if we talk about real jamming, high power jamming, there is for commercially available receiver, there's usually no mitigation. So as you see here, most topics are covered already by the GNSS product itself. And there is one topic the board designer could influence, which is the board design issue, if there is a topic there. You might even be interested in the hardware filtering if you build your filtering by yourself. This depends on the design you have, if you buy a chip or a module GNSS design. Okay, and then on the next slide, I'm ready to have an overview. What we discussed until now is RF interference can't be avoided. We have to handle this somehow. It can have a bad impact on your GNSS. Then we discussed about spoofing and jamming, which we treat as a security threat. It is also important to know that the GNSS receiver can detect this spoofing and jamming. and also that the RF interference mitigation can be done by the GNSS receiver itself. Let's say most of it, not everything. Okay, and now I have a couple of slides to go more in detail about the mitigation issues. So looking at now I refer to U-blox M9 product, and especially I look at a module product. The module product, you see a very rough figure on the right hand side, how it's built. So inside there's the U-blox M9 chip, and there is an LNA and some RF filter, a surface acoustic wave filter connected to the antenna. So this product, it offers really dedicated functions to mitigate RF interference. So the intention is that it still allows normal operation even if there is strong RF interference. Of course, everything has a limit. So it's equipped with this SAW filter, and the intention of the SAW filter is basically to reduce the impact of outband RF interference we discussed before. And then there is the chip. The chip has to handle the in-band RF interference by some filtering, and the filtering is basically part of the chip and the firmware. And the filters we put in here, they can handle some small band with signals with static or changing frequencies. And on the next slide, we go in detail and have a look how the U-blox M9 chip can do this in-band filtering. So for this one, we used a different setup to what I have shown before. So you see that now the low noise amplifier is connected to the antenna and the filtering comes after. This is a setup we use to show really this one case. And let's have a look at the right hand side. There's a diagram there. So what I show there is the red curve is the RF interference signal we increased step by step. And then there is the gray shaded area, which is the signal to noise ratio. This is quite important measure you can take also to verify if there is a problem. We will see later on also in the video we prepared that this will change, and this gives quite good indication if there is RF interference present. So this, you see, it's about a level of 35 dB hertz for quite a few steps of increased power in RF interference. And then if we look at this step from minus 20 dBm to 0, there's one step and you see a degradation of the signal to noise ratio. And this means the steps before the chip could mitigate it. So there's no impact on the GNSS performance for the first steps. Then this step, it influences badly the signal to noise ratio. But if we look now on the black line, this indicates if the receiver provides a GNSS fix, so position or time or velocity information or not. So it can still provide this information. But then the last step we show there with the red line, it goes to 0 dBm. And there the signal to noise ratio again reduces to below 20 dB hertz. And there the GNSS receiver loses the fix. So this shows an example, and basically this is also what you can verify yourself. Later on in the video you see how you can do it. So for 0 dBm, and this is why we changed here the setup, the low noise amplifier gets saturated, and this is basically the reason why we lose the fix here. Okay, so in the next slide, we look at outband interference. So here, this is a little bit more complex diagram on the right-hand side. So what is the setup here? Here we use a standard NEO module, which is equipped with the SAW filter, and basically we look how it behaves if RF interference is present. So a measurement we did here is that we put the maximum power level of RF interference to still let the receiver survive with this kind of signal. So it's a kind of an artificial setup. But you see there is the black line there. This is the maximum power level we applied, and it was a little bit limited by the test bench we used. So this is why you see only about 15 dBm power level. But this is already quite a reasonable power level, for example, if you talk about cellular transmitters nearby. And then I want to highlight the gray shaded areas there. So you see the behavior of the module for an 1800 megahertz signal and the behavior for 1800 or 1900 megahertz signal. And you see that the allowed power level the receiver can handle, it still is about 15 dBm. And then, of course, the curve at the center frequency of the GNSS, it goes very much down. This is what we discussed before, that there must be a different measure to mitigate the RF interference then. And the second point I want to highlight is the red curve. So this red curve is some product which will not be equipped with the SAW filter, and what the maximum power level would then be you can apply. And you see there's quite a big difference of about 30 dB. So in summary, we can say that the SAW filter or the filtering is quite important here. Otherwise, you will not be able to mitigate outband interference. In this module, also, we put the notch filter as well to especially mitigate the 800 megahertz band. Okay, that's for now what we can tell about these mitigation issues.
Thank you, Bernd. So let's jump to our last poll for today. We would like to know, do you check for possible RF interference problems in your board design? So please select one of the following: not at all, I would like to do it, but I'm not sure how to do it, or yes, we have expertise in this field. So your answers are coming in, and it's great to see that so many of you are voting. It's over 50%. Now it's over 60. Okay, so let me close down the poll, and then we will look at the results. Okay, so maybe this webinar is actually really of interest to you, because a lot of people have answered that you would like to, but you're not sure how to do it. And some of you also have expertise in this field. I think it's very interesting, and I hope that after this webinar you have some more clarity on this topic. And I will hand the word over to Bernd again.
Okay, yeah, thank you, Marlena, and interesting. So yes, I also hope that especially the little video we show afterwards, it can be some nice input for you. So here we show the setup. We will also discuss in the video. So U-blox M9 offers a new function to indeed have a look at the RF interference level in the in-band of the GNSS. And this is called the spectrum analyzer view. And here you see the setup you need. It's your RF interference board, basically, so some U-blox M9 board. and basically you have to attach a U-center PC to this application board to run this software. And with this software, we can later have a look if there is RF interference present. And now we prepared a video for you, and I will just comment the video while the video is running. Okay, Marlena, can you start the video, please? So as we discussed, a lot of wireless devices on the field, and they interfere with the GNSS. And also we can, I don't know if the video is really working. Does it? Marlena, did you start the video?
Yeah, I did. Might be some delay.
Oh. Okay. I don't know what happened. I don't see the video now.
Do you want to skip it?
Okay. Yeah. Okay. So the start we skipped it. So basically, U-blox supports you, of course, in this kind of stuff with our application engineers worldwide. And here we see the U-blox U-center software we can download from the web page. Here you see how it works. So it's free of charge. Just download it and install on your PC. And then for this video, we use special setup. We have a U-blox M9 Explorer kit here, and we connect to the PC. Then there's a signal generator. Basically, we use as an RF interference source, and we combine the signal generator with the normal satellite signal to the GNSS receiver. So this is the satellite signal window you see here. This is part of the U-blox U-center software, and there's now in the messages view, there's the possibility to enter this new function I introduced you. This is under the UBX section, and the MON section, it is called a SPAN, Spectrum Analyzer. And here you see how the spectrum analyzer works, and the shape of the signal shall really look like you see here on the window. And if there are peaks, this indicates RF interference. So we will see later when we switch on, then really the signal, what it means. So here you have the indication. There's the power level on the left, and there's the frequency on the top. And the curve, we can keep it using the view hold button, which we now did. And in the next step, now we switch on this RF interference source, and let's have a look how then the receiver behaves. So now you see the window looks different. The shape of the signal is now different, and basically this influences now the performance of the GNSS. On the top, we see this signal to noise ratio window, and this shows now black, blue, and red color, and so on, which means this is now a degradation in performance. And these kind of situations you should watch out really in your designs. This shows RF interference. So it is really important to check this kind of functionality, and with this spectrum analyzer, it's really easy to find out if there is any problem. So in summary, RF interference can impact the GNSS in a negative way, and U-blox M9 together with U-center can help to find possible issues. So I think that's all about this video. Sorry, it was lagging a little bit. I hope it still worked for you guys. Otherwise, we will later on we will upload this stuff on the web, I'm sure, and you can have a look at least at the presentation to follow this up again. So let me summarize about the whole seminar now. What we found out here. So the SAW filter in the RF path, it mitigates the outband interference. We had a look at it, how good this works if we have a good filtering there. Then it's also important to mention the signal to noise ratio, the indicator for presence of RF interference. And for this, you need the U-center software to have a look at it when you have your board design in front of you. And also, we discussed about the low noise amplifier. It can get saturated if there is really high power RF interference signal, and then it will degrade the signal to noise ratio, which you can see in U-center. And also, if there is the in-band filtering of M9, it can be M9 can detect then using the spectrum analyzer the in-band interference. And last but not least, the M9 chip mitigates the RF interference in the in-band automatically up to a certain limit. We had a look at this in this one slide. Okay, that's this for the summary, and then I want to mention on the next slide there is even more information available about RF interference. We publish now a white paper about reducing the impact of RF interference and improve GNSS performance now, and this will be available on our website. But also there's the product documentation of our products, and in the integration manual there's also some guideline and how to reduce RF interference. Beside that, there's also our application engineers, which always help if you need assistance.
Thank you, Bernd. This was a very great presentation, and yes, the video, I'm sure we can get that to you guys somehow afterwards, because it gives a very nice overview on how to handle RF interference. So actually, now we're going to jump to the exciting part of this webinar. I will hand over the word to Milena, who is ready to take your questions.
Thank you, Malena. So we have many questions, so we are happy that it looks like you're really interested in the topic.
And yes, just have a look at a few questions. Okay. I think we still have some time left.
We have 15 minutes left. So Hyun Lim is asking, we would like to know any mitigation tips for USB-free interference.
USB-3 interference. Okay, I'm not sure what that means. Maybe we need to clarify after the webinar. But please come back to us. I think we need to go more in detail because right now I don't know what you mean there.
Okay, so Pirmin Weitzer is asking, hi, is it possible to completely harden a GNSS device against spoofing, or do we have to assume that there is always ways to manipulate the position reporting from outside the device?
Yeah, I think it's an arm race. You always try to harden the receiver more and more, which is also in our scope. But of course, people will try to find a way around it. So also this is the same, I think, with the virus attacks we see on PCs. Of course, there's antivirus software, but there's also some clever guys who then invent something new. So hard to say. I think here we discuss not really about secure receivers. We discuss about receivers for the mass market, and we try to put a few measures in here. I think it very much depends what you expect. So first thing is really detecting it. The other thing is mitigating it, because for mitigation we might need also help of the application board. Right now the receiver just detects it, so it means your application board needs to handle the mitigation itself.
Okay, so we have a question about slide 22. If you start with a no fix and the RF interference signal is present, is there a possibility that the GNSS fix will never be acquired, even when the GNSS signal will become available? Americ Emmanuel Andrassi is asking.
Yes, I think an attack, also very common attack, is, for example, sending a jamming signal to what we discussed, disable basically the GNSS receiver first, so it needs to have a cold start with no GNSS fix at all, and then you start spoofing the receiver. This is a really bad attack, and this could mean that we will never catch really the right signal.
Okay, we have another question, pretty long. Okay.
Maybe take another one.
Okay. We have many questions, so we will see. Next, Uwe Latch. How good are the U-blox evaluation kits concerning RF board interference? Are they best as possible?
So we have two different kind of boards here. It very much depends on the design. There are different designs. For example, there is what I showed in the video. There's the Explorer kit, and there is also the evaluation kit. So, for example, for the evaluation kit, we use LNA to get really the best signal, which is then in front of the filtering. But this will be open for get this too much RF interference power, you know. So that's bad. So then we have the different maker boards also from the maker community. They build, for example, based on the Neo module, where we have filtering first, which is good against RF interference. So there are different designs. I think if you look at the Explorer kit and the evaluation kit, you will also see different behavior because of different parts used. So it's not always the same. You might look at also at boards made by the maker community.
Okay, so we have the next question. Hi, is the spectrum analyzer function available on the ZF9P module, or is it only present in the M9 line?
It's currently only available for U-blox M9.
Okay.
But we will make it available also on ZF9.
Okay, so now we have another question from Uwe. Is the function spectrum analyzer in U-Center only available with M9 or also with other products, M8?
No, we started with this functionality to provide it for U-blox M9. It's a unique feature of U-blox M9. Also, I want to mention that we improved, for example, if you select the module design, there is also an improvement in the SAW filtering of the module. And also I mentioned the notch filter of the U-blox M9 module. So there is a lot of improvement from M8 to M9.
Okay, so Moti Rahmilov is asking, can we get estimation on the SN degradation due to interference?
I think I don't know if I understand your question. You want to have kind of a measure. What is the signal to noise ratio you should have, or what is because it depends on your RF interference source, of course, what degradation you will see. I think for you it's important to know that we should see for example, in this U center, what we showed in the video, you should see let's say between above 30 dB hertz signal to noise ratio. Otherwise, the receiver will struggle.
Okay, so now we have next question from Emilio Montacana. Usually, how much the signal degrades with the insertion of the SAW filter?
Okay, this I don't. Degrades. You mean maybe you mean the insertion loss of the SAW filter. It's so the insertion loss is maybe about 0.2 dB. Of course, you have then a trade-off between more robustness of the receiver and a little bit worse sensitivity. So you might add another LNA. I think this you have to find out what is relevant for your design, because we know that some customers, they work really with low performance antennas. Then it could really be, you could get into trouble. If you have a better antenna, you might have still enough margin there.
So we have next question. What's your opinion on combined antennas, GNSS cellular, in one antenna?
Yes, I think this is could be quite critical, because then the isolation is low, and it depends. I mean, the case we are looking at here is, of course, that you have at the same time a signal from cellular and GNSS. If you use the same antenna, but you are not sending and receiving at the same time, it might not be a problem.
We have many questions.
We have 5 minutes left.
Yeah, so.
Just go ahead.
Okay.
Yeah. I mean, we can spend the time here.
So next question that we have. If we use another module, the Neo M9N, how can I analyze the spectrum of the received signal?
So I think you referred to the spectrum analyzer. So this is, at the moment, it's only supported by U-blox M9. So either you use the module or you have a chip set design. So there's also the U-blox M9 chip, or there's the U-blox Neo M9N module. We will also release more products later on. At the moment, that's the portfolio there.
Okay, so we have next question. Is it possible to use the spectrum analyzer function with the EVA M8?
No, it's only supported by M9.
Okay, which sequence is better, LNA SAW or SAW LNA?
Oh, that's very.
Paolo is asking.
This is very big topic, and I think we discussed briefly already. Of course, if there is the LNA first, the benefit is that you will have higher sensitivity because the signal is then stronger, but the LNA can easily get saturated. For more robustness, we always prefer to put the SAW filter first, because this will take basically the interference away if it's in the outband. Because if the LNA is first, the LNA has to take all the energy if it's in band or outband. So it depends again on your case. I think if you face a problem of RF interference, you should put the SAW filter first. If you don't have this, then maybe the LNA first is good.
Okay, now we have a next question from Jay Patel. We have active GPS antenna in our device and installed on mobile tracks where another product's GPS gets suppressed when our extended GPS mouse antenna is installed adjacently. Any suggestions for debugging?
Oh, I think this we have to go in detail with our application engineers. Maybe not so easy to give advice here.
Okay. Okay, so do you have some golden rules about PCB to reduce any possibilities of crash interferences?
I think with the spectrum analyzer, you have a handy tool to check for yourself, as shown in the video, and then I can only refer to our application engineers. So if you can share, for example, details of your board design, we will try to give you some advice. There's also, if you look into our product documentation, there's also, let's say, a guidance, as I mentioned in one of the slides there.
Okay, now we have next question. So we have 3 minutes left. With the usage of spectrum analyzer in U-Center, does that replace usage of noise level, AGC, and CW jamming levels in U-blox MON-HW in U-Center to determine interference with the system is affected by interference? Would the U-Center spectrum analyzer work with all the products, such as Lear 6R?
Okay, so quite a few questions here. So now no, it doesn't replace the other functions. It's an additional functionality we offer here, because this is also, let's say, limited to really the design phase of your product. So the spectrum analyzer you can only use, let's say, in the lab. It's nothing you can let your customer use. And this just accomplished with the other functionalities we had. The second question was about Lear 6 products. So as I mentioned before, this functionality at the moment is only supported by U-blox M9.
Okay, we go to the next question, probably the last or one of the two last ones. Hi, USB free interference with GNSS should be critical. Okay, the topic of this webinar.
Yeah, maybe we have to go in detail. I not have enough to share there, let's say, but we could look into it.
Okay, so next one. What are some interference mitigation techniques to solve conducted interference, for example, through the VCC pin?
Yeah, I cannot answer at the moment. I think with the tool we presented in the video, you can detect if there is a problem, but how to resolve the problem, I think there are different measures apply.
Okay. So for now, we don't have, unfortunately, time to answer all the questions. However, we really appreciate your interest in the topic. So please stay short that we are going to answer them probably by email. So for now, that should be all for Q&A.
Thank you, Milena, and thank you, Bernd, for answering all of these sometimes tricky questions. If you have any more questions, here are some places you can turn to. You can always check out our forum. It gives a very good overview on different topics, not only RF interference. I also want to make some promotion for our upcoming webinar also on GNSS. Well, it's about Mastering the Timing of GNSS. It's on March 3rd at 10 a.m. We will make some noise on social on that as well. And with this, I just want to thank everyone for watching. We really appreciate that you are coming to our webinars. As Milena mentioned in the beginning, don't forget to fill out the survey, which will be sent to you just now. Let us know what you thought of this webinar, and hope to see you next time. Thanks so much and have a good day.